Good afternoon, everyone. I'm Jenny. Right now, I currently work as innovation coach and computer science. Today, my topic is empowering mind using code to boost innovative learning. Okay, so before we get started, I want to introduce you guys to two pioneers in computer science. First one, the Ada Lovelace. So I think recognized, he is always recognized as the first programmer in the world. And despite living in an era where computer was not invented, and she envisioned the computer's capabilities beyond the mere numerical calculation, and to also imagine the computer can compose music. And forward 100 years later, we meet another giant, Alan Turing. Maybe you guys are familiar with him. During the World War II, he cracked the Germans' Enigma code and ended the war sooner and saved countless lives. He also proposed the Turing test and considered it the father of the artificial intelligence. To honor his contribution, the highest award in computer science, Turing Award, is named about him. So Turing Award established in 1966. It is regarded as the highest, as the Nobel Prize over computing. So it is awarded annually by the Association of Computing Machinery to individuals who have made substantial contribution to the computing. Since its inception, there have been over 70 recipients. Many students and parents ask me, the undergraduate majors, or whether they need to study computer science. So let's take a look at the undergraduate majors over Turing Award winners. According to the data, 47% chose mathematics and 20% chose electronic and electrical engineering. 50% study physics, and only 4% majored in computer science. Interestingly, there are 34% over Turing Award winner pursued mathematics and computer science at a PhD or doctoral level, respectively. So this data suggests, starting with their fundamental discipline like mathematics, physics, or electronic engineering can be highly beneficial in their undergraduate majors. So in particular, math is considered the cornerstone of computer science to provide essential problem-solving skills and logical thinking abilities. When we talk about programming, many programming languages come to mind. So Python became very popular with the rise of artificial intelligence. C and C++ have been the significant staple for over 30 years, constantly ranking top programming languages. With so many options, students always ask me, so which language should I learn? The truth is, there is no single best language. It all depends on which one is best suited for your needs. You can think of the programming language as different kinds of paintbrushes. So you may choose different paint types to create your masterpiece. And similar, in the symphony orchestra, each instrument has a unique sound. To produce beautiful music when combined, programming languages are the same. A famous philosopher once said, the limit of my language means the limit of my world. When we apply this to programming language, it becomes clear the limit of our programming language means the limit of our technological creativity. the code, it's become powerful tools for learning itself. We can use to simulate, to analyze data, so turning abstract concepts into concrete understanding. So let's explore how coding can solve the mathematical problem by estimating the value of the pi using Monte Carlo method. So step 1, we draw a square with line length of 2 and inscribe a circle in it. So the area of the circle is pi, and then the area of the square is 4. And then step 2, we generate random points inside of the square and count how many points fall inside the circle. Step 3, we divide the number of the points inside the circle by the number of the points. The ratio is equal to their circle area to their square area. And then step 4, we multiply the result by 4, and we will get the estimate of the pi. So simulating this process is efficient. It reveals how increasing the number of points can improve the accuracy. Manually simulating 10,000 random points may take a long time, but with the code, we can quickly achieve the precise result. Next, let's visualize physics of projectile motion. So imagine throwing a ball into the air and then find the pulse. So we can simulate this process. And we can tell, by simulating this process, we're able to see the ball's trajectory and consider factors like initial speed, angles, and gravities. So the coding making the learning become interactive and engaging, transform the abstract formulas into real-world application. Coding helps us to understand the physics deeply. And the code plus X is an innovative way of learning that combines codes with any subjects. So coding is not just a tool, it's a discovery. Since it's open up new way to explore and understand the world. The learning becomes playground, not just a set of the facts to memorize. And we can use the code not only for learning, but also for creating. The code allows us to express, annotate, automate, and customize, especially for the repetitive task and their unique problem cannot be solved by existing software. So let's take a look at some examples. So this is TunePad. It's a platform for creating music by using Python programming language. So our grade 6 students, they create their own music by using Python programming language in the last semester during the Our Code event. And this is a collection of the amazing project created by using processing. Processing empowers people of all interests and backgrounds to learn coding and create with the code. By combining the code with the hardware, we can build robots and electronic projects, such as image classification system, or the time-lapse photography projects or system, or we can use the Raspberry Pi and camera formulas to measure the health of the plant with their infrared sight. Or we can have the keys to build a piano stair that play notes each step. So making their practice more engaging and interactive. So coding is not just a skill, it's a creative outlet. Let's code to learn, create, and innovate. Thank you.
Okay, the next three speeches have one unified topic, which is questioning the information that we receive, or we call it the societal dominating narrative that we receive. Beginning with how we define ourselves and how we perceive people around us, how we define beauty. Let's invite Catherine Tan to share her insights about this. Thank you.